Assalamu alaikum. Okay, hi everybody. We continue solving partial differential equation. We started with the kind of parabolic equation of this type here. We talk about one of the method, explicit method. So it was like this. This is explicit method here, just j. The only difference here now, just replace j by j plus 1. Here we are. We get implicit method. That's all. J plus 1 is level j, so when we are in level j here, you see, like this is level 0, and this is level 1, so in general this is level j here. So when on level j, so j plus 1 is unknown. Okay, just we will do as before, but now that's it here, j plus 1, and we'll find the methods. So when we apply this one, the definition of this one, put R as before, definition of this one here, and just substitute here. So as you know, this is delta subscript should be, not delta t, and it's not t plus 1, it's wrong. So this one here is not like this here. Okay, so it's mean here, apply forward difference with respect to j, but here when we say x, apply with respect to I. That's all. So when you put with respect to I, you can see I plus 1, I minus 1. But all of them remain as it is here, j plus 1. Left hand side, because delta t, we keep I as it is, and this is forward j, and this is j plus 1. This is it so. Just we would like to rearrange it, put j plus 1 on the left hand side, and j on the right hand side. You can see this is unknown here, one, unknown, unknown, unknown. So it is only this one here is the only one known. So this one should go to the right hand side. But anyway, it seemed to me they put it on the other way. They put it left hand side, and the right hand side put left hand side. But should be no problem. So here it is now. Imagine this is left hand side, this is left hand side, left hand side. So the only right hand side is this one here. It is one known. So one known, it means we write it this way. And three unknowns, so this I plus 1, I plus 1, minus 1, and here I, so this here 1, 2, 3. It means we have one equation with three unknowns, which we cannot solve. So we need two more equations. So in that case, if we put it like this way here, just I like to put it here. Suppose we have this here, and we have this point, this point, this point here. So how to do it? This is known. So now this is here. We need to know this one. We need to know this one. Well, this one is not very good here, so just I'll erase it. So now go back. So when we substitute this one here, the meaning of this one, just rearrange and just put it like this way. This is the method here. We write it again. Just apply the method like before. So here we have this function here, h equal 0.2, k equal 0.02, we can find r, or given r we find k. So in that case here we have to do this one. Well, when we write here use 0, 1, it means the boundary condition, which is known as 0, given. And y5, 1 also given on the right hand side, so both of them are given, because you know this is the here initial condition, and here boundary conditions. All of them knowns. So we'd like to find now the value inside. What are the value here? There are inside this one. So how to find this one? So when we write one equation with three unknowns, so here is the equation, just substitute the value here. So we found this one here, and substitute, we get now the method, our method, which is for that example. So now we know now at level J0, here J0, so we put j equals 0, substitute, we can see here one unknown, and one unknown, which means three unknowns with one unknown. So this equation. Now, so if we put now, for this equation, substitute several value of i's. So if you put I equal 1, 2, 3, and 4. So for I equal 1, just substitute in this equation, we get this one. Equation 1 with the three unknowns. And if you put I equal 2, we get this equations. I equal 3, get this equation. I equal 4, this equations. So we have 4 equations with 4 unknowns. Where are 4? Because here, like this one here, 5, 1, we know it. And like this one again, 0, 1 is somewhere here. Again, like this one, we know it. So there are 4 unknowns, which is system of linear equation. Rearrange it and go to next slide. It looks like this. So here it is, here, that one, after rearranging. So this one here just it says how to do it, how to find this one, and left-hand side, right-hand side. So all of this here can be written. 4 unknowns, as I said before, those are the unknown one, which can be written like this here. So it means we cannot know one unknown. We have to know all of them at the same time by solving this system of linear equations. So here, the right-hand side, we know it well now. This one, solve it somehow by either direct or any numerical method. We found the answer. It says symmetric here because we have some method designed for symmetric matrix. So here, just after we solve this one here, we found the answer. Well, now in general, this implicit method, it can be written like this. In fact, it is the diagonal, all of them have the same values. Upper triangular and lower triangular are also minus r. So it's always come in this way. So it is nice that we know it looks like this. If you like to write a program, like in the book, so it can be written in general. So this is really which is called implicit method, which mean 1, 2, 3, and here 0.1, which mean 3 unknown with 1 unknown. Okay. Now we have to repeat again, but for another method called Crank-Nicolson method, CN method. What is a crank-like method? Okay, just I'm rewriting again here, explicit method here, this is J, implicit method, this is J plus 1. So what is a Crank-Nicolson? They took the average of this one. Left-hand side here, same as this one. So this plus this divide by 2 and a change, remain as it is. Here it is. But the right-hand side, we have to take this one plus this one divided by 2, which is really here, this one, plus the other one, and here divide by 2, which means the average. So this is J plus 1, J. And here is the method, that's it, finished. So just rearrange as before, write R equal like before, K divided by H square. And this one here, delta here, this should be here, not delta X square here, delta X square below here, not on the subscript, delta square, and here also delta square, not delta X square. So it should be written like this here, delta square X. So, but anyway, so when we apply it here, it is correct here now. Correct. No, here not correct. Here is correct now. So when we apply this one, both of them same things, but look here, this is J plus 1, this is J. So look here, this is same as this one. But one of them J, one of them J plus 1. So now put J plus 1 on the left-hand side, and J plus 1 here, and J plus 1, and put J on the right-hand side. So we have this system. So in that case, it should look like 3 unknown on the left-hand side, and the 3 known on the right-hand side. So it looks like this. This is a Crank-Nicolson methods. So just as before, how can we use it? Just we'll give the simple example. The same example as before. So it seems to be not the same. This is different here. So it says here, apply Crank-Nicolson CN method for this problem, parabola equations. And this is the initial conditions. Both of them here at 1 and at 0 equals 0. And here is the boundary condition, this one. So remember that we are taking R equal 1, H equal this number, and K equal 0.04. So how can we do it? Just he is repeating again, and that method can be written in this way. Just when we substitute, this can be rearranged like this. And now when we put R equal 1, this will disappear, this will be 0. So we have to put it now. This is the method. Now we have to use the boundary conditions. When J equals 0, what is the answer? Well, here is the when J equals 0, it means this is here when we start from this, the initial conditions. It means xi, so here when you put here I and t is 0, it means I 0, replace x by xi, so sine x pi. So this is really the answer. So we have to say sine pi IH for I equal 0 is known, I equal 1, 2, 3, 4. So in that case we find all the starting point. So now next to this one, so here we have to put this one to find all this value. Okay, here the answer in fact. With 0, 0, sine 0 is 0. 0, 1, it means here like this one, 0.1. Sine of this one calculated. This one here 2, it means 2 times h, here it is, and then calculated, here it is. Because of symmetry, this equal the previous one, and this one equal this one. And sine the other boundary condition 5, 0, which we know that 5, 0, 1, it is sine pi, which is 0. So in that case here now, we know this here, the initial, where j equals 0 here. So here, now j equals 0 is known now. So that case also, we have to find out the next level. Now go to next slide for next level. So here it is here, the equations. So substitute j equals 0. It means left hand side this becomes 1, 1, and 1. So we obtain this one here. Left hand side is 1 here, 1 and 1. It's unknown. But 3 unknowns with one right hand side is known, with one equation we don't know. So here when you put y equal 1, so here we got this, the first equations. This is bound from known, no problem. So we get this equations. If you put I equal 2, we get this equation. Rearrange it like this. If you put I equal 3, I equal 4, it means we found 4 equations with 4 unknown, we can solve the problem. If we put this one here, we will go next slide. Just if you rearrange it carefully, it looks like this. And the diameter here, diagonal, all of them the same, 4, 4, 4, but upper triangular here -1, the same as this one. So this is a system of linear equations, 4 unknowns, but the right hand side is known. We solve it and we obtain the result. So in that case here, we know Crank-Nicholson. Just as a quick summary, this is here explicit method, and this then implicit method like this, and then this is Crank. Why? Okay, we take implicit or Crank-Nicholson, while explicit is very simple. The reason explicit method is stable or converge only when r between 0 and a half, but the other one are unconditionally stable and converge. That's the reason. Okay, thank you very much and see you next time.